So before we start, I'm just gonna So in this video, we're going to be talking about init containers. Now, init containers are a little bit like the normal containers in pods, but there are some key differences around whether they can support startup probes and liveness probes. They don't. And a few other things around how resources work. But generally speaking, they're used just to make sure that things happen or things are true before your main container starts, essentially. So if you set up 3 init containers, they will run sequentially on how they are defined to completion. And if they don't complete, your main container for the pod won't start. If they do complete, that's when your main container starts. We'll go through an example or two here just to show you how they work, why you'd use them, and when maybe a startup probe or liveness probe might be more appropriate, I guess, because you can do a certain amount of things with that, checking TCP endpoints are up and running, but maybe you need a DNS record to be responding before your pod starts, or before the container within the pod starts, or the containers within the pod start. In that case, yeah, maybe an init container will do. Maybe you need to change some permissions on a file before the container starts, in which case, yeah, again, init containers can work. So, or maybe you just need to pull some data before the main container starts. Again, init containers can do that for you. So they're really useful. Let's get into a few examples now and show you how. Like I said in the last video, this is going to be a quick one. So understanding init containers. Basically, it's what I said at the start. Init containers always run to completion and they must complete successfully before each one starts, before the next one starts. So if a pod's init containers fails, then basically your app won't start. The main container will not start, or the containers will not start. They differ from other containers or the main regular containers because they don't have lifecycle, liveness probe, readiness probe, or startup probes. And that's because they must run to completion before the pod can be ready. So there's no point in having those things. They also have to run sequentially. And also there's a little bit of difference around how the requests and limits for resources work. So we can jump down and have a look at that. I'm not going to read through all of this, but the main point to note is that, well, this one here. So the highest resource limit defined will be the one that is used. So if you have 3 init containers and you define a resource, requests and limits for all 3 of them, the highest one will be relevant. Okay. So okay, there's a little bit more on that here, but that's it. I don't want to sit here reading through the docs. You don't want to sit on a video where I just read docs. So let's have a look at some examples and use cases. So this here is basically doing a loop 100 times, and every 1 second it will do an NS lookup for a particular service. If it completes, then great. If it doesn't exit 1, and that basically means it fails. So that's one example. Maybe you're waiting for a service to come online for a different pod, so that's one thing you can do. Another one here, for example, is registering the pod with an API endpoint to say, this is the instance name or the instance name and pod IP. You might just want to wait 60 seconds before starting your app. You might need to clone some data into a volume that will then get attached to the main application that you want to make use of. And in another scenario, you might want to mount a config map, like a really basic template config map, where you then modify a few things, store it as an actual file on a volume, and then that volume gets mounted into the main app and that becomes the configuration. So there's a bunch of different things you might need to do. So that's some examples there. I'm just going to do a really basic one, more to show you how it works than anything else. So I just want to show you what happens when things error. I want to show you how to write them out. You need to think about whether these are relevant to you, really. Is the stuff that needs to happen for your application to run successfully? If so, then this might be the answer to your question. Okay, so there is some scenarios that they're useful, and they might just look at these and go, I don't need these. My app runs without all of this stuff. Let's have a look. There is some examples on the website, so you can have a look at these. I'm just going to do a really basic one though. So we'll jump over to the IDE. We'll do API version. I've just got a new file here called pod.yaml, nothing fancy. We'll do v1, we'll do kind of pod, and then we'll do some metadata for this. We'll give it a name of init example and a namespace of learning. We'll then do some spec. So that will just drop a few things in. We'll do an Nginx one because, good old Nginx. We'll do an image with Nginx latest, and yeah, just go for latest. That's fine. I usually go for versions, but I don't really need to in this case because we're not bothered about Nginx itself, but it's there. So we'll just do ports next, container port 80, and give that a name of HTTP. So there we go, there's that. Good old Nginx just runs as normal. But let's say I need to wait for some reason for stuff to happen before this actually runs. How I do that is I'd write init containers. Again, we give it a name. I'll call this sleeper, and we'll do a image of, I don't know, let's just go for busy box latest. It should work, I think. I am freestyling this, as you may have just noticed, and we'll do a command, and the command will be, let's think, we'll do sh-c, and we'll do a for loop. So we'll do for I in 1 to 20, and then what we'll do is we'll echo I, we'll sleep for 1 second, and then we're done. So if this works, then what will happen is the pod will start. This will run first, this init container. And once this is completed, it's 20 loops of echoing I, or echoing the number in this case, and then sleeping for 1 second. It will then go ahead and run the container. But that's a little bit boring. Let's do another init container on top. So we'll do another one with name of say hi, and this will, again, we'll just do image of busybox and latest, and then we'll do a command in here where we again we'll just do sh-c for a command, and then we'll just echo pod IP. And what is pod IP? Well, that's an environment variable, so we're going to need to do an environment on here, and we'll call this pod IP, and it will be a value from, and we'll do field ref, field path, and the field path will be the status.pod IP. So once this pod is running, it'll get an IP for the pod, and this will get inserted into this container as a environment variable, pod IP. And that's basically it. So we can run this now and it will work. But what I'm actually going to do is I'm just going to do one more up here. And all I'm going to do in this is just do exit one. So I'll do exit one here. So we can see here that something's going to fail. And I'll go ahead and do kubectl, apply f25 pod.yaml, and over on my terminal, we will do kubectl, get pod into its learning, and we will just watch that for a second. Ignore all this. This is just historical stuff from previous videos. So I'll just drop down a few lines and we will just go ahead and apply that pod now. So we'll do that, jump over here, we should see an error. So we've got 3 init containers, as we can see here, and it's not gone up by any. So this running ready value is the application container. And then we've got these 3 init containers running. And the fact that hasn't gone up one means the first one has failed. So what we could do is kubectl, get pod, describe pod, namespace, learning, and init example. And in here, we can go ahead and see that failed to create a task, run C, create failed, unable to start container process, exit one, executable file not found in path. Now, the reason for that is because I was supposed to run shell -c and then exit one. I didn't do that. I just ran exit one. So it can't find that command. There is no command called exit one. If I did, for example, let's just jump back. I'll go ahead and delete that now. So that's one example of an error is the point there. So what I could do now is change this to shell and -c, and then just exit one. So I'll go ahead and apply this one. We will describe this one, and you can see here we've now got a started container fail. This is going to be looking slightly different. So here we had a run container error. This means there was an error running the actual container, and that error was that it couldn't find the command I was trying to run, which was just exit one. Now we have a different error. We're still getting a crash loop back off, but it is an error all the same. So what I could do in this case, because it's failing, I could do kubectl logs f and then the name of the pod. However, you'll notice here, we now need to specify a particular container. So it defaulted to Nginx, but obviously Nginx isn't running, it's still initializing. So now we need to put -c on the end and put the name fail, because that's the container that's failing. So I'll run that. There isn't any logs, but if there was, then we would see some logs here. Okay, so just a quick example of what that might look like. We'll do echo failure of pod, whatever that failure might be, and then we'll exit one. So again, we'll just delete and apply, and I'll jump back over here. We'll run this command again, and we will now see failure of pod, and that has failed in the same way. So that's what failures look like within init containers. You can soon determine which one has failed because you've got this number here that's 0 of 3, so it didn't even get one running, so it's the first one that failed, and that's pretty much it for failures. Okay, so let's jump back over and remove this. We don't need that anymore. And we'll go ahead and delete and reapply, and let's look what happens when it succeeds. So we'll jump back over and we'll check that out and see what's happening. And we have a new init error. So that's interesting. What did I miss? I've missed something here. In fact, here's the perfect example. So we'll jump back up. We'll change that fail to sleeper because that's now my first init container. What did I miss? I missed do on the for loop. Yes, I did. Silly me. Okay, so I just needed to do there. So I'm saying for this, do this, and then done. Okay. I didn't even need to show you the first error because I created one anyway. So back to the original task at hand. Let's have a look. We've got this first one running that ran. So yeah, there we go. That's going. The second one's run, and we've got the pod up and running. Let's go and see what happened there. So let's have a look at the sleeper. It just did 1 to 20. Okay, that failed miserably. I did the command wrong. Oh, unbelievable. It actually just echoed out that. What did I do? Oh, dear me. I can't see off the top of my head why that didn't work. Let's have a look at the example. They had an example of it. So they did 4i in that. Yeah, that's what I've done. I've probably done something silly. It doesn't matter. You can see what happened there anyway. It doesn't actually matter. You know, it did it. It ran. I'm just trying to dig myself out of a hole here. It ran. It slept for a second. It echoed that out. It's fine. I can live with that. It's not a problem. Now the next one was the say hi one. So let's take a look at that and see if that actually worked. And yeah, there we go. We got the pod IP there. So that's great. We got that printed out. So the for loop didn't work exactly as I wanted it to, but I'm just going to pretend that wasn't a problem and that didn't really happen. If we take a look back at their examples, they have a little bit more to theirs. They have the main container and, you know, they basically go through and do until ns lookup my service dot, and then they get the namespace dot service dot cluster dot local. Okay, so that's just saying basically it's doing an internal DNS lookup for this particular service, an internal DNS lookup for this particular service, and once that's up and running, the container can start. So I'm guessing what they do. In fact, let's copy this and see what actually happens. So if I grab that, what I'm expecting will happen here, because they haven't given us the service, I'm just going to delete that one first. We'll go ahead and paste that in. And I suspect what will happen here is this will just sit waiting, because this is an until command. So until this resolves, you're not going to get an answer. Basically, it's just going to wait, sleep 2, and then keep going. So yeah, so we'll just go ahead and run that. And then we should see it's actually not in the learning namespace. So I'm just going to have to change that a second. Yeah, okay, so it's in here, look. And if we have a look, we should just see, so we'll do qctl describe pod that, and it's just sitting there. It's not really doing anything, is it? It's, you know, there's no errors, there's not doing anything, it's just sitting there. So the reason is it's waiting. It's just waiting. Okay, so what can we do to make this work? Well, what we can do to make this work is give it a service, really. That's all. I imagine that's what's about to happen in the example. So if we scroll down to a little bit further, yeah, so that's fine. It is just sat there as it said. And if we describe it, we can see those waitings. Yep, that's fine, because this first one's running. And if we look at ours, we can see that's also true. So if I scroll up a bit, we've got this running section here, and that's just running, looking for this. So I suspect what's going to happen is they're going, yep, there we go, services. So we'll grab that. We'll just put it in below this. It's not going to make a difference to the running pods. Okay, so that'll create 2 services. So go ahead and apply that. And we should see now, I probably won't even catch it now. This should sleep every 2 seconds and then start running. So just give that a moment. And there we go. It happened in the background while I was just doing a describe. It did that. It did it running. Let's have a look at the logs for this. And again, it will default to the main container, but you can specify an init container if you want to. And there's the app running. So there's an example of something you might need to do. You might need to check to make sure service is online and running somewhere else in the cluster before your app comes up. So I think that's where I'm going to leave it, because that's pretty much everything you need to know there about init containers and how they run. You can see, you know, hopefully my bad example and this example here showed you some use cases, the way you might use it. My example didn't do that because mine was just a for loop. You know, it's there all the same. But this one, again, gives you a better example. There is a bunch of things you can do with it. Like I say, pulling data down into a pod into a volume for a pod is a prime example of that. So have a little play around, and that's it. I'm going to leave it there. And that's it. That's where we're going to leave init containers for now. I told you it'd be a pretty short one in the last video. We're going to talk network policies in the next video. Now, this is going to be a fairly broad topic that I'm going to try and compress into a 15 to 20 minute video, I'm going to say, because I don't want to drag it out too long, because there's so many variables around network policies. But we'll just do a basic one where we allow the web front end to talk to the database backend, and that's it. So yeah, I guess I'll see you in the next one.